मेरे चैनल में आपका पुनः स्वागत है एंड लेट्स गेट राइट इनटू द वीडियो. ठीक है. सो द फर्स्ट क्वेश्चन or the question we're looking at today is basically the arc length of cone videos. So basically this is your cone, right? We're basically going to be looking at the arc length or the sector thing. So let's get into the video. So let's read the question thoroughly first. A coin has radius r centimeters and height h. Okay, that's not useful. If r is equal to 5 and h is equal to 10, find. Okay, now let's draw a quick sketch of a coin for ourselves. So, yeah, that's a pretty reasonable cone, I would say. So, the saying is the radius is 5. So, radius is equal to 5 and the height is equal to 10. Okay, so question number one. Okay, the slant height of the cone. Fairly simple on it. So they want us to find this area, okay, the slant height. So we know what to do. This is basically Pythagorean. Okay, so square root 10 squared plus 5 squared, and that should give us, let me punch that into my calculator, 10 squared plus 5 squared. Okay, my bad. 10 squared plus 5 squared. Okay, that is 5 root 5. Chalo. So the slant height of the cone, fairly simple, 5 root 5. Now part B. Let's erase that. I'll write 5 root 5 here. And let's go part B. So part B, the surface area of the curved part of the cone. Okay. Nothing too challenging here. So we know they're asking us for the curved part, otherwise also known as lateral surface area. So we know that the surface area of a cone is pi r squared plus pi r l. So the lateral surface area is just this bit, because pi r square comes from this top square area. So pi r l, that's what we're going to focus on. So let's take pi r l. Okay. And let's substitute our information in. Pi r l, okay. So pi multiplied by r, which is 5 in our case, into l, which is our slant height, 5 root 5. So doing this will give us 5 into 5 root 5 into pi. It will give us almost something close to 175. Let me just double check the answer for you guys. Yes, that will give us 25 pi root 5, which is equal to 175.62 centimeter square. Okay, fairly simple only at this point. This is not the point of the video. The point of the video is for these two questions. Fairly simple, but it took me a long time to figure it out. So hopefully you guys understand it very soon. So they're asking us the angle of the sector, okay, we get if we cut the curved part of the cone. So the angle of the sector if they cut this cone. So let's draw the net of the cone. So the net of the cone will look something like this. Okay? So the reason why it looks something like this is our actual circle, let's say if this is a circle, right? Our sector is just this one bit. So to draw it more realistically, let's say that's our bit. Yes. So that is our sector and that is the entire circle. So joining these two lengths will get us to our actual thing. I know none of this makes absolute sense. So let me actually get into solving the question. So let's draw the net, fairly simple. And the angle of the sector we get if we cut, they want this angle, okay, theta. Let's name it as theta. They want theta. So now what we are going to do is, if you think about it, the slant height of the cone is actually the radius of the bigger circle which this sector is cut from. So the radius, this one, this bit is 5 root 5. So the radius of the bigger circle, right? Because just remember, this cone is a sector from a bigger circle. So its radius, if you think about it, is the slant height. I will show you in another video a practical project of me unboxing an actual cone. Okay. Let's leave all the fun to the side and let's get into the actual project. So that's 5 root 5, the radius. We want to find theta. And what other information do we know? Or what other information must we extract from there? Well, from here we know that the radius of the circle is 5. How can we put this into any use? Well, if the radius is 5, let's find the circumference of this cone circle. So circumference, if you remember, it's 2 pi r. So the circumference is 2 pi r. So if you put that 2 pi into r, which is 5, we get 10 pi. Not 110 pi, 10 pi. Okay. So that is 10 pi. Now, leave that to the side and let's find the circumference of the actual big circle from where this sector was taken. So if the radius is 5 root 5, then the circumference of this whole circle is 2 into pi into 5 root 5. 5 into 2 is 10. So it's 10 pi root 5. So that's the circumference of the bigger circle. So now we want to find theta, isn't it? That's our main objective. So the proportion of 10 pi, sorry, let me increase the font size. So the proportion of 10 pi over 10 pi root 5 must equal to the proportion that theta as over 360. Do you get it? This theta's proportionality context to this proportion must be the same as the circumference of this to the rest of the circle. So now let's solve for theta. So theta is equal to, let's take 360 to the other side. 360 into 10 pi over 10 pi root 5. Now, carrying this out, we can strike out 10 pi and 10 pi. So theta is simply equal to 360 over root pi. So in our case, theta is equal to 161 centimeters. So not centimeter, 171 degrees. Okay. That is what the question asks us to do. Now let's look at B. B is asking us if R is equal to H. Okay. If R is equal to H, find the angle of the sector that produces by the curved part. Okay, so it's the same question, but now they're saying us that the radius is no longer 5, but the radius is 10, because that's what they've told us. Okay. Chalo. So we do the exact same thing again. Pause the video now, try this on your own, and then release it to watch me do it. So let's speed this up a bit because we know what to do now. So we need to first find the ratio. Why is this super big all of a sudden? We need to find one extreme or the other extreme. Okay, so we need to first find the ratio of the circumference of the sector to the whole circle. Then we can equate it to the ratio of area of like the angle theta over 360. Okay. So let's get into it. So now let's draw another cone. That's 10. So the circumference of the circle is equal to 2 pi r, which is 2 into 10, which is 20. So it's 20 pi. Then if we take the biggest circle, we know that if this is 10 and that's 10, this is equal to 10 root 2. Our slant height is equal to 10 root 2 if you do Pythagoras, 10 squared plus 10 squared. Okay. So now that's 20 pi. Then circumference of this, we know this is the radius of the biggest circle. So 2 into pi into 10 pi. 10 root 2, that's equal to just 20 pi root 2. So 20 pi over 20 pi root 2 is equal to theta over 360. And now if we solve for theta, theta is equal to 360 into 20 pi over 20 pi in 20 pi root 2. We can cancel out 20 pi. So theta is simply equal to 360 over root 2. So if you notice in both these cases, it's just this root that gets laid behind. But I'm not trying to teach you any shortcuts in this video, but that is just basically how you answer that video. Thank you for watching.